fine-tuning will save time later. Step 2, Option 1. Setting up the first post using tripods for stability. Determine the most advantageous location to start the erection of EFCO deck equipment. This is usually in a corner or along two intersecting walls for lateral support. Chalk only a single straight line to set the center line of the first row of EFCO deck. Chalk only one X-axis and one Y-axis, and the EFCO deck system will take care of the rest. Set up your first post by using the EFCO deck tripod for stability. Unfold the tripod and evenly space out the legs. Hook the post with the tripod and secure by tightening the wing nut. Step 2, Option 2, setting up a module of EasyDeck. An alternate method of starting an EFCO deck setup is to start out with a more stable first module of EasyDeck. This single 4-post setup with EasyDeck panels will give a firm, stable pillar of strength for lateral bracing, both during the setting up of EFCO deck and during the pouring operation. EasyDeck and EFCO deck are designed to work together. Once the EasyDeck module is set, you can tie on in all 4 directions with EFCO deck primary beams and secondary beams. Most times, EFCO deck users will strip out the handset EFCO deck a piece at a time. When it is time to move the EasyDeck stabilization module as a full setup, move it assembled from floor to floor. Step 3. Hang a primary beam. At this point, we should have a corner post either stabilized with a tripod or an EasyDeck module with an Easy Shore post. Hang a primary beam from the drop head. Step 4. Adding a second post. Using a second post, hook the free sloping end of the primary beam with the drop head of the second post and push up until the primary beam is level and the post is vertical. Stabilize the second post with another tripod. Step 5. Second set of posts. Repeat steps 3 and 4 for another set of posts separated by your secondary beam spacing. Step 6. Adding secondary beams. The next step can best be handled by a readily available rolling scaffold supplied by others. From the rolling scaffold, lay in secondary beams and space each to match the 4x8 plywood sheet layout. Step 7. Continue setup. Continue working from your 4-post startup tower by hanging primary beams, pushing up with posts, and then dropping in secondary beams between the primary beams. Step 8. Stabilizing edges. Stabilize all free edges of the EFCO deck shoring by installing X-bracing, handrails, and tie-down brackets before allowing individuals up on top of the shoring for plywood installation. Again, follow all safety guidelines and applicable codes at all times. Step 9. Lateral bracing requirement. Appropriate and adequate lateral bracing for an EFCO deck setup is an absolute requirement for safety. A qualified customer job site engineer must check each total setup for lateral stability. Many times the in-place concrete columns and shear walls provide this lateral bracing as long as the setup is caught between or attached to the permanent concrete part of the structure. Without the building structure's vertical concrete for stability, EasyDeck towers can provide the lateral bracing. The diagonal 2x4 added bracing to the posts is another way to provide lateral bracing. Step 10. Drilling a plywood deck for penetrations. There are only a few times when penetrations are required through the plywood deck. As an example, when a pipe must be poured in place in the concrete without a sleeve forming a hole, or without drilling a hole in the slab after the slab has been poured. As a warning, a penetration drilled through the plywood after the shoring setup is in place must not touch or penetrate the EFCO deck shorehead, primary beam, or secondary beam. Failing to follow this warning, drilling through the primary and/or secondary beams could cause a shoring failure of the member and also the destruction and replacement of the shoring support beams. The EFCO deck system using a plywood deck makes it easy to complete the plywood closure around concrete columns and along walls. A concrete column can fall anywhere on the grid of primary aluminum beams in one direction and secondary lightweight steel beams in the other direction. Because plywood will normally cantilever 5 inches beyond a supporting member, this many times will handle closures up to walls. If the center line of a post falls more than 7 inches away from a column or wall, the EFCO system uses the drawer effect to move standard primary beams in to meet the existing concrete column. With the EFCO deck system, you can place primary beams on both sides of a column and use a standard 2x4 or 4x4 wood beam to span between them. This way, the primary beam will fit up snug against the column and the wood will easily support the plywood deck. See your EFCO erection drawings for more details. Cycling equipment. Step 1. Relieving the load. Relieve the load in the framing members, primary and secondary beams by hitting the drop head load relief nut ear. This causes the primary and secondary beams to drop 4 inches. Step 2. Strip relieved equipment. With the drop head relieved, primary and secondary beams, along with loose plywood, can be stripped. Stack neatly and fill the carts and roll to the next pour. Warning: you may want to stack the racks 2 racks high for moving equipment floor to floor. For ease in handling, it is best to put the heavier post item in the lower bin of 2 and the primary and secondary beams in the upper rack. All materials moved with a crane from floor to floor must be securely strapped to the rack for the move. Left behind are only posts with drop heads and plywood trapped by the posts. These will remain until sufficient strength is reached by the slab to support its own weight. Step 3. Removing posts and installing reshores. Once the slab has reached sufficient strength to support its own weight, move the hitch pin from the inner hole to the outer hole on the load release pin. Relieve the heaviest load on the post by tapping the load release pin to its secondary position. Any lesser remaining load on the shore post can be loosened by turning the load release barrel nut at working height. The handle of the load release nut has been designed so that a straight claw hammer can be easily engaged in the handle to rotate the nut. Note how the base plate end of each post has been designed to provide neat, easy, and orderly stacking of posts in the carts. Because reshoring depends on the early strength of concrete, a specialist employed by the contractor must evaluate the strength of concrete and the reshore system before removing shores and placing concrete above. The specialist shall determine the levels of shoring and reshoring to safely support the fresh concrete, and the specialist shall determine the age of the concrete when stripping and reshore operations may proceed. Once all the posts are relieved of load and removed and the slab is allowed to deflect, reshore posts can be installed. To prevent reshores from falling over, install a reshore spring on the top of each reshore post before reinstalling the post. This is to keep the post from falling during the post tensioning of the slab above. As each reshore post is installed, adjust the shoring screw to flatten the reshore spring on the slab above. Do not tighten the post beyond flattening the spring, as this may cause loads to shift between reshored slabs. The reshore springs have a special design to clip on top of a shore. If you have used nails to attach the plywood to secondary beams, the secondary beams may need to be pried off the plywood after the drop head is relieved. It is recommended to use a maximum of 6 nails per sheet of plywood, unless you have a good reason to do otherwise, and only nailed to secondary beams. Many times there is a requirement to cantilever out beyond a last post to support a working platform. This is handled with a special one-ended primary aluminum beam approximately 10 feet long. This special cantilever beam is normally used with 6-foot 0-inch post spacing that limits the amount of cantilever to 3 foot 6 inches from post or 2 foot 6 inches from slab edge. In addition to adding the 10-foot primary beam, there are several additional accessories that may be required, and they are the cantilever beam bracket, tie-down bracket, hold-down clip, handrail post, T-bolt, and ratchet straps supplied by the contractor. A cantilever beam bracket is used when the post needs to be attached along the primary beam. The tie-down bracket slides on and is tightened to the primary beam. A strap connects this to a floor anchor in order to prevent toppling of the cantilevered primary beam. This system may be used for wind resistance on high floors. The hold-down clip slides and tightens on the primary beam to clip the drop head. It is used in all cantilever situations in order to prevent toppling of the cantilevered primary beam. Handrail posts along with 2x4s are attached to the edges of the system to create a safe working area on top of the shoring. Do you have a new employee or even a new crew? This need not be a problem with EFCO Deck, because EFCO supplies coordinated support, including this step-by-step training video, product catalog, EFCO erection drawings, and job site field service. This is all part of EFCO's wraparound support. EFCO provides you with a support team ready to service your project. The members of your EFCO team for your project are the district engineer to assist with engineering questions, the plant manager for questions regarding shipments and returns of equipment, and the EFCO field service representative for all on-site planning, form erection, and cycling support. In addition, EFCO has the district sales administrator for coordination of the team and possible billing questions. We are also available to help you on your next project. For more information regarding the EFCO Deck system and other EFCO forming systems, contact your territory manager at 1-888-BUY-EFCO or on our website at efcoforms.com.